you. Thank you. So first, sort of a, it doesn't work. It's working. Okay, so just like a callback to the first talk. I'm scared too, I guess would be. So yeah, I'm just going to do it scared. And this is a callback to the senior panel. We didn't touch on one thing that I have a pretend, what's it called?
Persona.
No. Imposter syndrome. Thank you very much. So that's why I write as senior, not senior. And yeah, luckily for you, I'm not going to be doing the talk as Prison Mike. So so the name of the talk is GCP Cloud Run Optimisations, but I didn't know that all of you were doing catchy titles. So I made an executive decision and renamed it to how I fixed the problem I created in the first place. Yeah. So yeah, first off, I'm by no means an expert, especially in GCP, because before I joined my current team, I had my certification for AWS. So yeah, then I joined IKEA and they run on GCP. Okay, so screw it. So yeah, there are going to be a couple. So this is more of a detour from what you've been hearing up until now. So no more soft skills, more on the technical side. Hard skills, yeah. So yeah, this is the just to describe the problem. At IKEA, teams mostly communicate between each other via PubSub. So in order to get data from another team, you are bombarded by a bunch of events that you need to process. So my team decided to do that on Cloud Run, and we have an existing Cloud SQL, Postgres running. So we did that with Cloud Run. Otherwise, this talk would have a different name, I guess. So yeah, we decided to run everything on Cloud Run, and those were the requirements. So around 100 million messages, and the idea was to run it in under 4 hours, with the database not grinding to a halt, so below 90% usage, because we have a 10 to 20% usage background. And once those 100 million messages are received, the same system is going to be then doing just the deltas. And it can be run multiple times, so in case something goes wrong. So yeah, my team is in the process of rewriting everything. So that's why we picked Quarkus and Kotlin, and with Postgres. So after a while, with dealing with Quarkus, because it was new to everybody, and Kotlin, and dealing with protobuf, because that's how the messages are sent by the other team. It was time for the first run. So yeah, the first run took 40 hours. It's going to work. Yeah. As you can imagine, the performance was bad across the board. Oh, it's it looks really bad. So the request count was low, the latency was high, the memory and CPU usage was slow, surprisingly. So yeah, as you can imagine, lots of foul language was used. But then I thought, wait, I should know how to fix it. I'm a consultant. Yay. So yeah, I started with DuckDuckGo because that's how I roll. And eventually I ended up on Google. If you use DuckDuckGo, just do G and exclamation part, and it redirects you to Google. Then I found a bunch of Stack Overflow threads that mostly made no sense. But among those stuff that I checked out, there are a couple I thought that I would present. So starting with the first one. Optimized container startup. Because instances are scaled up as need be, they need to start quickly. So the idea here was to use smaller container images, either by using the slim ones, slim versions, or zip, which is for Java specifically. Speeding up boot time, so don't do complex stuff on start. yeah, this one actually didn't like using the CPU boost during startup actually didn't make much of a difference. But apparently, this is good to know that there are some JVM versions that are quite slow to start, but that's because they're not container aware. For us, the difference, we switched from an Uber jar to a native image, so the startup time went from 8 seconds to 8 to 10 seconds on average to under 1 second. But yeah, that in general didn't make much of a difference for us because we kind of found other better approaches, I guess. So the next one would be to use minimum instances. Again, this is not something that directly affected my team, but it was worth pointing out that if you don't want cold starts, just put minimum number at 1. And if you can see here, like this obviously means that this product was built by developers, because who in their right mind would allow this to happen? Like if it's under 3, you might experience downtime. What? So I don't know. Like it's obviously built by developers. So. Yeah, next one is use global variables, which kind of sounds wrong, but it's not, because once the instance starts up, you can just reuse the same global scope. Yeah, just make sure that you're doing stuff that's concurrency friendly, and yeah, don't rely on request persistency. So it's going to probably go to a different instance. Yeah, the kind of in same line with the previous one is do some lazy init if possible, so that you don't do it on start. Fortunately, Kotlin has this buy lazy thing, so it's really simple to do that. So the first time it's accessed, it's going to do the class with heavy initialization, otherwise not. This one is mostly useful for Quarkus does this automatically, connection pooling. So it uses JDBC pulls underneath. But the interesting part here is that this is the default. So CPU is allocated only during request processing, which is great because you don't get charged much. But the downside is that all of those stuff like JDBC pooling, collecting of metrics, async method and stuff like that is done in the background. So that means as soon as the request is returned, the CPU goes away and everything stops. So when the next request comes in, it's going to continue with the previous stuff that was in background. So it's, for us, the better approach was to use it so that it's always on. And yeah, the final idea was, yeah, you need to pay special attention that while your stuff scales, that the other parts of your system do not go down. So max instances times connections per instance, that it has to be less than the max connections allowed, which kind of makes sense, I think. Yeah, this is probably the part that you're going to be stuck on the most, because there are only a couple of things that you can control in Cloud Run. So that's how much memory and CPU you give it, the request timeout, and how many concurrent requests there are. But that doesn't mean that it's limited to 80 requests per second, that 80 requests simultaneously. So it might, if you just look requests per second, it might be a lot higher. So the idea here is that while it's still not good, you just go optimize the performance, deploy, adjust the concurrency settings, load test, and if performance is bad, go to 1. If not, go to 3 and just repeat until you get a good result. Yeah, sort of an intermission. If you haven't used K6, is awesome. I used it to load test stuff locally because I didn't want to deal with redeploying all the time, and just gave me faster feedback. I don't know if you can, yeah, you probably can see it, but yeah, it just starts up 300 threads and just bombards the GCP endpoint that's created for this one. So yeah, the Cloud Run, for Cloud Run, you create a container which exposes just one usually just one endpoint, and everything from PubSub was directly, like all the messages were pushed directly to this endpoint. Okay, Yeah, this one is a big one as well. So Quarkus uses, we used Panache from Quarkus, which is just a layer on top of Hibernate. And yeah, if you ever used Hibernate before, when you check which queries are made, you usually get a surprise. So you need to, yeah, mostly because you're not using it correctly and you learn it how you're supposed to use it and then forget. So yeah, using explain, analyze is something that you do often. You need to check that the correct indexes are used, and yeah, obviously add missing indexes. And yeah, just transfer only the data that you need, which is, yeah, I can optimize it here. As you can see, just like on average, just one row is returned. Or better yet, yeah, just keep the query if possible. I showed in one of the previous slides, I just used, because the amount of messages, like a lot of them were duplicated, so I it was just an internal cache that was running and just keeping those. Yeah, again, a few words about the autoscaler. The autoscaler evaluates a couple of parameters every 5 seconds, and it checks, I think, the last minute or two of the execution. So if CPU utilization is above 60%, it's going to spin up new, or it's going to decrease. If the if the request concurrency hasn't been reached, it's going to increase or decrease again. And if the min-max instances haven't been reached, it's going to do the same. So yeah, you don't want this to happen. This is the CPU utilization, and yeah, it jumped to 100%. So when that happens, nobody else can do any work. Yeah, and while I was checking out this, what to do, what to fix, how to change stuff, I came across an interesting approach. I thought I would share as well. This is from a YouTuber called Richard He. In it, he's using Cloud Run Job, which was released in GA in April this year. So Cloud Run is mostly, its main intention is to be used for executing long-running tasks that are preferably run to conclusion. Container does not respond to an HTTP request like it does with the Cloud Run, the regular one. So in this example, we're using pull instead of push, so you're not relying on that. And in theory, it should use less resources. But this was one thing that I found really concerning. I guess there's no built-in way to scale up or down. So in this case, you need to rely on kind of a strange system. So we have here like PubSub, that's and Cloud Run Job, which is scheduled. It's triggered on a schedule, and then it starts pulling from PubSub, and does that for 2 minutes, and then it kills itself. And then you have another Cloud function, which is also triggered on a schedule, and checks the metrics for PubSub. And if there's too many messages stuck in there, it just scales up and deploys another Cloud Run Job with 100 concurrent tasks, which is okay. Again, yeah, you're probably not going to see this, but yeah. So this is just a basic approach of how to do that. Quarkus has one nice thing that you can actually use it either for building HTTP applications or even for CLI ones. So to create a CLI one, you just use the same code and just add a Quarkus main, and then you have, where is it? Just the run method. You override that and just starts pulling messages and just wait for it to exit. And then you have a scheduled, which is delayed, scheduled function, which is delayed by 2 minutes, and it then just kills itself. Yeah, and just it starts pulling messages. Yeah, and as I mentioned, this is the one. So this cannot be changed at runtime. I guess you need to deploy again and change this variable. But other than that, there's like mostly the same stuff. You have CPU, memory, the timeout. It even goes up to a couple of hours. Yeah, and number of retries if it fails. But yeah, in the end, I kind of decided that this had too many moving parts, too many stuff that needed to be maintained. It was also really hard to test. So the previous example with the Cloud Run container, it just You just send it a bunch of messages and it's going to gladly process them. With this one, it's harder in every sense, I guess. And as soon as you started, like the database that we're using, it immediately just spiked to 100%. So it's a little bit too eager, I guess. Then you can have different triggers. This is, for some reason, they just expose the to trigger it on a schedule, so cron-based. But there are also like event arc you can use, or workflow, so that you can have complex steps that happen one after the other, I guess. So after that, we did another run. And the final run took 2 hours and 40 minutes with most of the stuff that I mentioned. Actually, the engineering manager said that if we could get it under 4 hours, he's going to buy us drinks. So we got drinks. we got drinks.
How much money did you save?
Well, if you just check the execution, it's a lot. As you can see, around 10K, the request latencies were really, I guess, kind of low, under 0.1. And in the end, we used 20 instances, but we had to limit this because otherwise it brought down the database, basically. Kind of lessons learned, I guess. Performance tuning takes time and patience. You need to analyze your queries carefully, especially if you're using some ORM, because it might be doing some silly things underneath. The fastest query is the one you don't execute. Sorry. In my opinion, Cloud Run just feels like that it's not like feature complete. Like stuff is missing. Like even updating some stuff. I don't know. This is more meant as a joke, the last one. I still like serverless, but it's just like, why is it so difficult in some cases? So some resources. That's it from my side. 20 minutes. Bang on.
Oh, no, you have, look at that. Well, you also have time for some questions.
Okay. Sure.
And we have plenty. Okay. Whoa. All right. We'll start Domen, Clement, and then Sasha, and then BC. Oh, wow. Okay. Just hand it to each other.
Yeah. I'd like to say again, I'm not an expert. I just play one on TV.
So you mentioned you went from 40 hours to 2 hours and 40 minutes.
Yeah.
If you could expose one thing which was the bottleneck and one thing which gave you the most performance optimizations out of all the stuff you did, what would you say?
I was stuck in that loop for a long time. So optimizing, the first step was optimizing queries. Like I cut that down to just a few with the help of that. And the rest of the time was more or less spent in that loop, just trying to get it to that sweet spot, just like not overloading the system, going as fast as possible without causing issues. That was probably the biggest one, because like the UberJar for native, I don't know how familiar you are with Java, but with Java it's usually quite CPU intensive. So, but as soon as you go to the native one, the CPU and memory go down, but that comes with other problems because now the autoscaler is not going to scale up. So it's a double-edged sword, I guess.
Thank you.
So if the goal was to process X million events, so what was the price for processing that event? Did the price per event go up, go down? I know that you had used some CPU always on settings and stuff, so how was the price per event?
Lucky for me, I work at IKEA at the moment, and they don't care about that stuff. They care about like the bottom line, but in this situation, they were switching from a system that was much more expensive than this one. So I guess it's just, and then the other system's going away. So this is a brand new system that it's meant to be working for a long time. So that's why we also picked serverless. And as soon as the base load is over, we're gonna switch it back off so that it's not a CPU always on because it's like, I don't know, a couple hundred events per day. So it doesn't make sense. It just spins it up, and it doesn't need to be fast after that. But just like the first base load needs to be fast. So in that case, they just said, screw it. Just nobody said anything.
It's fast, right?
Yeah. They just said, just make it as fast as possible. That's it.
No matter the cost.
Well.
You have good stakeholders.
You mentioned connection pool.
Yeah.
Did you think, or are you thinking about doing not client-side connection pooling as well, like a PG bouncer or something in front of the database? Or do you not scale up so much so that it matters?
No, we didn't think of that. Might ask you a couple of questions later on.
Okay.
I guess, but yeah, I guess why we didn't go that. I guess it worked well enough.
Yeah.
So
I assume that was the case.
yeah.
Who's next?
Mine's not technical, but I'm super interested, and maybe you have already said it, I didn't catch it. What type of system actually requires 40 hours of execution time? What are you working on? Just to get a context of... No, just to get the context of, you know...
No, oh, you mean what data
Yes,
we're importing?
yeah.
Just stuff that IKEA sells. It's 100 million messages. I'm not joking. So,
Yeah, but what type of messages? I mean, what does your team...
just like it goes item by item, language by language, so you have a bunch of them.
Uh-huh.
So it's like it goes, yeah, there are four, we had to subscribe to 4 different topics. One was for the structure, like business structure, like HFB, PR, APA, whoever's in IKEA know what that means. So that's one. Then you have the translations, because each item has a name and they did it that way. The other two are, for some reason, I'm blanking on the other two, but yeah, we need to, yeah, four were, but yeah, primarily is like my team is dealing with discounts, so you need to have all the items available.
Yeah, I understand.
To
Okay.
create discounts.
Thank you.
So you have a good discount.
No, I'm afraid I can't do that. I don't have access.
Yeah, just one more. Did you ever consider that maybe the Kotlin is not the best backend language?
not Kotlin. No, Quarkus was the one.
Yeah.
Yeah, that I was playing around with Ktor, which is the JetBrains one. But yeah, at that point, yeah, we were so far along down that road, and we kind of, as a team, decided it's going to be Quarkus and Kotlin. So making it something completely different was kind of okay. No, just leave it like this, because somebody after me is going to have to fix it. So yeah, but yeah, Ktor is an option as well.
We don't Ktor.
Sorry.
We went with Ktor instead.
Yeah.
How come you decided for Cloud Run in the first place? Of all the GCP sort of compute services that you could use?
Not really sure what was the DuckDuckGo. Yeah. They just wanted to build something serverless, so I guess that Cloud Run gives you a little bit more control over what's in the container. I guess you could use like Cloud Functions instead.
Yeah, or you could use something like just a virtual machine for the base load and then into a function. It would probably be
yeah.
a
But yeah,
cleaner
the main thing was the current solution runs on Kubernetes, and that's mega expensive. So.
Okay.
So yeah.
No? Okay. Thank you again, Senor Developer Engineer.